Good day, everyone. We are the Group 5, and today we are going to present and discuss our given topic. So we're requested to please focus on the screen and listen carefully.
Good day, everybody. So today, the first topic to discuss is item analysis and validation. So first, I'm going to share about the objectives of item analysis and validation. So it is used to explain the concepts and principles governing item analysis and validation. It also is used to validate dummy data and perform item analysis and validation. Another is to verify the reliability of a given data or test questions through computations. So here is the brief introduction of item analysis and validation. So the concern of this lesson is that in order to ensure that the final version of the test would be successful and functional, the teacher normally prepares a draft of the test which is subjected to item analysis and validation. He or she tries out the draft test to a group of students of similar characteristics as the intended test takers, which is in the tryout phase. From the tryout group, each item will be analyzed in terms of its ability to discriminate between those who know and those who do not know, and also its level of difficulty, which is in the item analysis phase. The item analysis will provide information that will allow teacher to decide whether to revise or replace an item, which is included in the item revision phase. Finally, the final draft of the test is subjected to validation if the intent is to make use of the test as a standard test for a particular unit or grading period. That is according to Navarro Rosita et al. In 2019. So, next slide. So, what is item analysis? Item analysis, by the way, is a process of examining class-wide performance on individual test items. So here are the uses of item analysis. The first one is efficient class discussion of the test results. Next is the remedial work. The third, general improvement of classroom instruction. The fourth one is increased skills in test construction. Then the last, we have constructing test banks. So in the right side, what are the characteristics of item analysis? The first characteristic is item analysis is the examination of individual items on a test, rather than the test as a whole for its difficulty, appropriateness, relationship to the test, rest of the test, etc. The next one is item analysis is useful in helping test designers determine which items to keep, modify, or discard on a given test, and how to finalize the score for a student. The third one is if you improve the quality of the items on a test, you will improve the overall quality of the test, hence improving both reliability and validity. So the last one is item analysis test the effectiveness of the items by studying the students' responses of each item. So next slide will be the benefits of item analysis. So the first benefit would be it gives useful information for class discussion of the test. For instance, essay items can be treated lightly. Responses to difficult items can be explained more comprehensively. And defective items can be pointed out to the students. So the next one would be it gives data for helping the students to improve their learning method. For instance, if a student commits a number of incorrect responses for several items, this reveals misconceptions of the learning tasks, which should be taken into consideration for remedial work. So the last one is it gives insights and skills which leads to the construction of better task items for future use, according to Calmarin 2011. So here are the common types of item analysis which provide teachers with 3 different types of information. So the first one would be difficulty index. So difficulty index, it refers to the proportion of the number of students in the upper and lower groups who answered an item correctly. So teachers produce a difficulty index for a task item by calculating the proportion of students in class who got an item correct. So the name of this index is counter-constitutive, as one actually gets a measure of how easy an item is, not the difficulty of the item. The larger proportion, the more students who have learned the content measured by the item. So here is the formula of computing or getting the difficulty index. So index of difficulty, DI equals to RU plus RL divided by NU plus NL. So where DI is equals to difficulty index, RU is equals to the number of students who got the correct answer from the upper group. RL equals to the number of students who got the correct answer from the lower group. NU is equals to the total number of students from the upper group. NL is equals to the total number of students from the lower group. Here we have the example of an item difficulty index. So we have here, for example, you have 50 students in your class. So 50 students, for example, number 1. So 0% or 20% only got that item correct. So you would level that item as very difficult. So if 0.21 to 0.40 got the correct answer, you would label it as difficult. So 0.81 to 1, it is very easy. So the next slide will be discrimination index. So the discrimination index, it refers to the power of an item to discriminate the students between those who scored high and those who scored low in the overall test. It is the basis of measuring the validity of an item. This index can be interpreted as an indication of the extent to which overall knowledge of a content area or mastery of the skills is related to the response of an item. So here we have the formula. So index of discrimination or ID. So RU minus RL divided by NG, where ID is equals to discrimination, index of discrimination. RU is equals to number of students who got the correct answer from the upper group. RL is equals to the number of students who got the correct answer from the lower group. NG is equals to the number of students in either the upper and lower group. Example of level of discrimination. So if the index range is negative 0.1 to negative 0.50, so it is interpreted that can discriminate, but item is questionable. So the action you need to take place is disregard. So we have here, if the index range is 0.51 to negative 0.51 to 0.45, so it is interpreted as non-discriminating. So the action needed is to revise. So the last example here is 0. If it has the index range of 0.46 to 1, so it is interpreted as discriminating item. The action you're going to make is included. So the last is the analysis of respond options.
In addition to examining the performance of an entire test item, teachers are often interested in examining the performance of individual distractors or incorrect answer options on multiple choice items. By calculating the proportion of students who choose each answer options, teachers can identify which distractors are working and appear attractive to students who do not know the correct answer, and which distractors are simply taking up space and not being chosen by many students. To eliminate blind guessing, which results in a correct answer purely by chance, which
Hurts the validity of a test item, teachers want as many plausible distractors as is feasible. Analysis of response options allow teachers to fine tune and improve items they may wish to use again in the future classes. So that's it for my part. The next one is we have Mr. Ybañez.
Thank you, Ms. Pantinople. So let's proceed with item analysis procedure. There are several item analysis procedures that may be applied, but for informal achievement tests, the UL method or the upper-lower method is the simplest procedure. In other words, only the upper group or U and lower group L scores are considered. The middle or average group is held Ybañez. For example, the table will show the result of item number 20 taken by 45 students until a test which is subject for item analysis. So this is the example data for item number 20. Record the scores of the students with their corresponding answers to item number 20. So C is the correct answer for number 20. For step 1, arrange the test scores from the highest to the lowest score. So in step 2, get 1/3 of the papers from the highest score and 1/3 from the lowest scores. The former group is called the upper group or U and the latter lower group L. Set aside from the middle group. In the foregoing example, 15 papers from the upper group and another 15 papers from the lower group should be analyzed. The scores and the answers of these papers for upper and lower group are as follows. For step number 3, count the number of students in the upper and lower groups, respectively, who choose the options. For step number 4, record the frequency from step number 3. The frequency may also be recorded on the item card or on the separate sheet. These are as follows. For item number 20, number of students in the upper and lower groups, respectively, who choose the options, which is the correct answer is letter C. For upper group, only 11 students who choose the option C, and for lower group, only 6 students who choose letter C. For step number 5, estimate the index of difficulty. In determining the index of difficulty, simply use the following formula. Index of difficulty is equal to summation of x divided by n times or multiply by 100, where summation of x means sum of right responses or upper or RU and lower RL groups. And N it means number of students both from the upper and lower groups. In the above example, there are 11 students from the upper group who got the correct answer and 6 from the lower group. By substituting the formula, the index of difficulty of the above example is 57%, which means the item is average or moderately difficult. To illustrate, for number 1, index of difficulty or DI is equal to RU plus RL divided by NU plus NL equals 11 plus 6 divided by 15 plus 15. So 11 plus 6 is equal to 17. 15 plus 15 is equal to 30. Therefore, you need to divide 17 and 30. And the answer is 0.5666. And you need to convert it. Therefore, the answer is 0.57, which is average or moderately difficult. To get the percentage, this is what you need to do. Index of difficulty is equal to summation of x divided by n multiplied by 100. So 11 plus 6 divided by 30 multiplied by 100. So 11 plus 6 is equal to 17. Then you bring down the 30 and multiply by 100. So 17 divided by 30 is equal to 0.5666 multiplied by 100. So therefore, you get the answer 57%, where summation of x means RU plus RL, and N means NU plus NL. Difficulty refers to the percentage of getting the right answer of each item. The smaller the percentage, the more difficult the item is. The higher the value of the index of difficulty, the easier the item. Hence, more students got the correct answer, and more students master the content measured by the item. For step number 6, estimate index discriminating power. In estimating the index of discriminating power, consider the difference of the right response between the upper group, or RU, and the right response from the lower group, or RL, divided by the number of pupils in each group, or NG. The formula is as follows. So, index of discrimination, or ID, is equal to RU minus RL divided by NG, is equal to 11 minus 6 divided by 15. So 11 minus 6 is equal to 5. And bring down 15. So 5 divided by 15 is equal to 0.3333. And you need to convert, so therefore the answer is 0.33, which means discriminating. So the index of discriminating power is obtained is 0.33, in which item number 20 is reasonably good item but possibly for improvement. The discriminating power of an item is not more 1.0. For the last step, determine the effectiveness of each option. All options, including distractors or wrong response, must be analyzed to determine if they are effective. A good distractor attracts more students from the lower to choose as their answers than in upper group. So the next reporter is Miss Christine to report validation and validity and reliability.
So next is validation and validity and reliability. This lesson covers the purpose of validation in order to determine the characteristics of the whole test itself, namely the validity and reliability of the test, Navarro Rosita et al. 2019. After performing the item analysis and revising the items which need revision, the next step is to validate the instrument. The purpose of validation is to determine the characteristic of the whole test itself, namely validity and reliability of the test. What is validation? Validation is the process of collecting and analyzing evidence to support the meaningfulness of the test, Navarro et al. 2019. What is validity? Validity refers to how well a test measures what it is purported to measure. It refers also to the appropriateness, correctness, meaningfulness, and usefulness of the specific decision a teacher makes based on the test result. Why is it necessary? A teacher who conducts test validation might want to gather different kinds of evidence. There are essentially three main types of evidence that may be collected. So number one is construct validity. Is used to ensure that the measure is actually measure what it is intended to measure, and not other variables. Using a panel of experts familiar with the construct is a way in which this type of validity can be assessed. The experts can examine the items and decide what that specific item is intended to measure. Students can be involved in this process to obtain their feedback. So the second one is criterion-related validity. It is used to predict future or current performance. It correlates test results with another criterion of interest. So the last one is sampling validity. Similar to content validity, ensures that the measure covers the broad range of areas within the concept under study. Not everything can be covered, so items need to be sampled from all of the domains. This may need to be completed using a panel of experts to ensure that the content area is adequately sampled. Additionally, a panel can help limit experts' bias test reflecting what an individual personally feels are the most important or relevant areas. So the next slide will be reported by Miss Karen Beriarmente.
So thank you, Ms. Aragoncillo. The next slide is all about reliability. What is reliability? Reliability is a degree to which an assessment tool produces stable and consistent result or the consistency of the scores obtained. There are types of reliability. The first one is test-retest reliability. Is a measure of reliability obtained by administering the same test twice over a period of time to a group of individuals. The score from the time 1 and time 2 can be correlated in order to evaluate the test for stability over time. The next type of reliability is parallel form reliability. Is a measure of reliability obtained by administering different versions of an assessment tool. Both versions must contain items that prove the same construct, scale, knowledge, base, and etc. To the same group of individuals. The score from the two versions can then be correlated in order to evaluate the consistency of result across alternate versions. The next one is inter-rater reliability. Inter-rater reliability is a measure of reliability used to assess the degree to which different judge or raters agree in their assessment decision. Inter-rater reliability is useful because human observers will not necessarily interpret answer the same way. Raters may disagree as to how well certain responses or material demonstrate knowledge of the construct or skill being assessed. In the last part of types of reliability is internal consistency reliability. Internal consistency reliability is a measure of reliability used to evaluate the degree to which different test items that prove the same construct produce similar results. Average inter-item correlation is a subtype of internal consistency reliability. It is obtained by taking all of the items on a test that prove the same construct. Regarding comprehension, determining the correlation coefficient for each pair of items, and finally, taking the average of all of these correlation coefficient. These final steps yields the average inter-item correlation. Next is split half reliability. Split half reliability is another subtype of internal consistency reliability. The process of obtaining split half reliability is begun by splitting in half all items of the test that are intended to prove that the same area of knowledge World War II in order to form two sets of items. The entire test is administered to a group of individuals. The total score of each set is computed, and finally the split half reliability is obtained by determining the correlation between the two total set scores. So the following table is a standard followed almost universally in education tests and measurement. So here's the table. Reliability of 0.90 and above, its interpretation excellent. Reliability at the level of the best standardized test, very high reliability. 0.80 to 0.90, Its interpretation very good for classroom test. High reliability. 0.70 to 0.80. Its interpretation good for a classroom test. In the range of most, there are probably a few items which could be improved. Average, moderate reliability. 0.60 to 0.70, somewhat low. The test needs to be supplemented by other measures. More tests to determine grades. There are probably some items which could be improved. Low reliability. 0.50 to 0.60 suggests need for version of test unless it is quite short. 10 or fewer items. The test definitely needs to supplemented by other measures. More tests for grading. Very low reliability. The last one is 0.50 or below. Its interpretation questionable reliability. This test should not contribute heavily to the course grade and it needs revision. To determine the reliability of the test, number 1, test-retest method. The same measuring instrument is administered twice to the same group of students and the correlation coefficient is determined. A Spearman rank correlation coefficient or Spearman rho is statistical tool used to measure the relationship between paired ranks assigned to individual scores in two variables x and y. Thus, this is used to correlation the scores in a test-retest method. To obtain the value of Spearman rho are considered the formula. So here's the formula. Rs is equal to 1 minus to 6 summation of d to the power of 2 is divided to 3. N minus n, where Rs equals Spearman rho, summation of d to the power of 2 equals sum of the squared difference between rank. So the n is a total of number of cases or students.
To apply the formula, the steps are as follows. Step 1. Rank the scores of respondents or students from the highest to the lowest in the first set of an administration, x1, and mark this rank as Rx. The highest score receives the rank of 1, second score, third highest score, 3, and so on. Step 2. Rank the second set of scores, y, in the same manner as in step 1 and mark as Ry. Step 3. Determine the difference in ranks for every pair of ranks. Step 4. Squared each difference to get d squared. Step 5. Sum the squared difference to find summation d squared. Step 6. Compute Spearman rho Rs by applying the formula. So the second is internal consistency method. The method of obtaining this method is determined by Kuder-Richardson Formula 20. The Kuder and Richardson Formula 20 test checks the internal consistency of measurements with dichotomous choices. It is equivalent to performing the split half methodology on all combination of questions and is applicable when each question is either right or wrong. A correct question scores 1 and an incorrect question scores 0. The test statistic is par q of 20 equals k over k minus 1, open parentheses, 1 minus summation of g to the power of k equals 1 pj qj over q squared, close parentheses. So here is the example of computation using Excel.
That is it for item analysis and validation. So for the next topic, may I call on Ms. Resty Mia B. Lerio?
So thank you so much, Ms. Karen Faye Pantinople. So for the second topic to be discussed is the measures of central tendency and variability. So central tendency along with the variability of a data set, central tendency is a branch of descriptive statistics. So we should never forget, class, that central tendency is one of the most quintessential concepts in statistics. So when we say quintessential, it represents the most perfect or typical example of a quality. So by learning this topic that we will be discussed to you, class, we can be a person who is a quintessential, a person who is the perfect example of something. Or maybe in the future, that quality of a person serves as our way to become an effective teacher. So let's claim it Beteled too. So we have objectives for this topic. So for the first one, it uses to explain the meaning and uses of the measures of central tendency and dispersion. It uses to compute the measures of central tendency and dispersion manually and in Excel. And the last one, it uses to interpret the data score through normal and skewed score distributions. So the first lesson is the introduction to statistics and its importance in assessment. So research-based inquiry is more effective at achieving learning. We seek truth and reality through science based on empirical perception, which is known as statistics and or quantitative data analysis. So when we say quantitative data analysis, class, is all about analyzing number-based data. So what's the definition of statistics? Why we need to go deeper on that word. So statistics has always been perceived as one of the most challenging subject areas among school students. So according to Garfield and Benz v. 2008, statistics is considered as a difficult subject to learn due to the complexity of statistical concepts. Understanding of statistical concept is different from understanding the mechanics of statistics, which involves plugging numbers into the correct formula. And then students who can understand the statistical concepts have the ability to read and use tools such as percentage, ratio, measures of spread, central tendency, and variability, as well as tables, graphs, and maps, according to Australian Bureau of Statistics. So next, statistics is the branch of mathematics that deals with the collection, organization, presentation, computation, and interpretation of data, which are the outcomes of learnings. There are two general types of statistical analysis. The first one is descriptive statistics. It is used to summarize a collection of data by describing what was observed using numbers or graphs. It includes mean and standard deviation. Useful in communicating the results of an inquiry, particularly experiments or surveys. The last one we have, or the letter B, as what you see on the screen, is the inferential statistics, also called predictive statistics. When we say predictive statistics, it uses methods to draw patterns in the collected data and then makes conclusions, predictions, or forecasts about a group or about a process being studied. The conclusion may take the form of like in letter A, answering yes or no questions, or what we call hypothesis testing. The letter B is estimating numerical characteristics of data, and we can also call that one as estimation. The letter C is describing relations among data or correlation. And then the letter D is modeling relationships among data, like for example, predicting, forecasting, or estimating. And the last one is extrapolation and interpolation. So class, extrapolation and interpolation are both used to estimate hypothetical values for a variable based on other observations. So next, we have statistical methods. Statistics is useful in the teaching learning process along several research-based inquiries. The first one is experimental studies. Inquiries causes in addition to drawing conclusions on the effect of changes in elements being studied. The second one is inferential studies. This does not involve any experimental group and control group. It uses data and correlations between intervention. So next is the importance of statistics in assessment. The use of statistics can help in the whole process of outcome-based teaching and learning. This entails the process called conceptualization. And also, statistics help you distinguish between acceptable and doubtful conclusions by allowing you to assess statements based on quantitative evidence. When analysts appropriately apply statistical processes, they produce accurate results. And the third one is measuring and evaluating students' progress is an important aspect of the teaching and learning process. We acquired scores and then interpreted them in order to make decisions in this procedure. We can evaluate these scores objectively by the help of statistics. It improves the efficiency of the teaching and learning process. And the last one, a statistical examination of student responses to test questions can reveal which aspect of the curriculum the students are struggling with. This can be used as a tool to help your students improve in certain areas.
Measures of central tendency and variability. So it is a value that represents a typical or central entry of a data set. The three most commonly used are mean, median, and mode. Measures of central tendency. Central tendency measures are a summary measures that seeks to summarize an entire collection of data with a single value that indicates the middle or center of its distribution. The mean, median, and mode are the three primary metrics of central tendency. When data is properly distributed, the mean, median, and mode should all be the same, and they're all useful for displaying the dataset's most typical value. When assessing measurement of central tendency, it's crucial to consider the datasets of dispersion. The mean is the sum of all scores divided by the number of scores. The formula is m equals summation of x over n. The mean is also, example here is 7, 8, 8, 7, 3, 1, 6, 9, 3, 8. Then the sum of x equals 7 plus 8 plus 8 plus 7 plus 3 plus 1 plus 6 plus 9 plus 3 plus 8 equals 60. So the in here is 10. Then the mean is 60 over 10 equals 6. The disadvantage to the mean as a measure of central tendency are that it is highly susceptible to outliers. Observations which are markedly distant from the bulk of observations in a data set, and that is not appropriate to use when the data is good, rather than being of a normal distribution. The median or the middle score, when all scores are arranged from lowest to highest, the median of 7, 8, 8, 7, 3, 1, 6, 9, 3, 8 equals, it is arranged by lowest to highest. This is 1, 3, 3, 6, 7, 7, 8, 8, 8, and 9. So the median is the average or mean of the 5th and 6th scores. So the median is 7. And then the mode, it is the most commonly single number in the distribution. Measure of central tendency for nominal variables.
So earlier, Ms. Liangco already discussed about the measures of central tendency, and we learned that there are three types of measures of tendency, which are the mean, median, and mode. And now I am going to discuss about the measures of variability. It is very helpful, especially that if you want to find the exact answer of our data. So, in measures of variability, there are three types. But first, let's tackle about the range. So, what is range? So, the range of a data set is the difference between the maximum and minimum data entries in the set. So, in short, that The range is the difference between the highest data and the lowest data. So in order to get the range, we use this formula. So R, or the range, is equals to the highest data minus the lowest data in order to get the range. So that is the formula when we are going to using the or finding the range. So the next one is the standard deviation. So what is the standard deviation? It's the most common way of describing the spread of a group of scores.
Thank you. For the next lesson is outcomes-based teaching, learning, and score distribution. What is outcomes-based teaching and learning? Quite simply, OBTL is a student-centered approach to learning and teaching which has been widely adopted in universities across the world. Many teachers are initially confused about the differences between the concepts of outcomes, aims, and objectives, and do not understand why OBTL, which uses outcomes, is seen as more student-centered. So here is an explanation of the differences. For its aims, the aims of a course or program should be summarized broad purposes and goals. Aims can be aspirational and are not necessarily easy measurable. For example, we might have a set of aims or attributes for the city university ideal graduate, but this might, by their very nature, be more difficult to measure than intended learning outcomes for a particular course. For objectives, they are best seen as specific intentions that indicate the steps to be taken to achieve our aims or goals as teachers. They should be measurable and indicate the teaching intentions. For the outcomes, these describe what the learners will be able to do when they have completed their course or program. They are expressed from the student's perspective, so most outcomes statements begin with the phrase, "By the end of this course or program, you will be able to," followed by a short list of outcomes, normally around 5. Outcomes must be measurable and accessible. So therefore, outcomes are more student-centered because while objectives indicate the intentions of the teacher, outcomes are the specific measurable achievements of the successful student. So the next reporter will be Miss Ypanto.
So, this will be the continuation of Ms. Villalvito's report. So, what is the purpose of OBTL? OBTL approached the development of teaching and learning activities in enhancing student learning experiences, the design of assessment processes to monitor students' learning progress and the achievement of the desired outcomes and attributes, and the collection of stakeholders' feedback for continuous improvement. Constructive alignment provides the how-to by the stating the TLAS and the assessment task activate the same verbs as in the ELOs. Why use OBTL? The short answer is that OBTL is logical, effective, and both teachers and students find it more satisfying than traditional teaching. So all in all, OBTL is effective for both teachers and students.
So that's the end of our presentation, and I hope you learned so much this day and apply it in real life as we take this journey as a future educator. So thank you so much everyone for listening, and God bless you and keep safe everyone.